water break. Okay, check how we're doing. We're doing good so far. Okay. So, question number 11. Lewis structure. What is the Lewis structure for C2HCl? Okay. So with this, first thing we have to do is, count the amount of electrons we're working with. So carbon is on the 14th column of the periodic table, so that's 4 electrons it can help. And because there's 2 of them, that's going to be 8 total. H, that's just in the first column, so that's 1 electron. And Cl is on the 17th column, which is 7 electrons. So in total, we have 8 plus 1 plus 7, which is known as just 8 plus 8, which is 16 electrons that we're working with total. So the goal is that whatever Lewis structure we draw has to have 16 electrons total. So now, because carbons have the most unpaired electrons, we're going to put those in the middle. So C and C. And we're going to just even distribute 1 on each side. That's the goal here. So H and Cl. So we're going to add 1 bond here. That's what we're going to start with. I'm going to add 1 bond to each one. And now we're going to see from left to right how many electrons left they would have. So hydrogen is already sharing 1 of its 1. So hydrogen is done. Carbon, based on both sides, is sharing 2 of its 4. So it'll be 1, 2, 3, 4. Same thing with this carbon here, 2 of its 4. 3, 4. Chlorine, on the other hand, is sharing 1 of its 7. So it'll be 2, 3, 4, 5, 6, 7. And there you have it for chlorine. It satisfied its octet rule. Now hydrogen does not want the octet rule because it only had 1 electron to begin with. So what do we do with these unpaired electrons so far? Conveniently, we can actually just throw them in to form a triple bond in total between the 2 carbons. So if we were to redraw this now, we would have carbon, 1 bond, 2 bond, 3 bond, and still the same thing for the outside places. But now effectively we've gotten rid of these unpaired electrons. And the cool part is that when you count at the end, we should still have 16 electrons total. Let's see. 2, 4, 6, 8, 10, 12, 14, 16. So this is what we're dealing with for Lewis structure. And if you want to draw it in the bond form, it would look like that. That is what the Lewis structure would look like there. Now, just to make sure we did this correctly, we do have the right amount of electrons, but let's see the formal charge, okay? So hydrogen here, its formal charge is done by getting its valence electrons, which is 1, minus the amount of electrons it has by itself, which is 0 right now, plus the amount of electrons it's sharing, which is 2. And because it's sharing, you have to divide that by 2. So we really just have 1 minus 1, so that's equal to 0. Perfect. Carbon, doesn't matter which one you pick, but the carbon, alright, has 4 valence electrons. And the reason why it doesn't matter because they're both doing the same thing, okay? They have 0 by themselves, but they're sharing 8 electrons because there's 6 in that triple bond and then 2 from the hydrogen or the chlorine, and that's how we got 0 as well. And the chlorine, last one, 7 minus, has 6 to itself plus 2 over 2. That is also 0. And now we have the true sense. Formal charge is where if there was any, where the charge would be. Because it was a neutral molecule, we want to make sure that we all got zeros here. Because if there's like a -1 or +1, we did something wrong. So with that being said, they calculate the amount of valence electrons, Then they're able to now draw it out with the Lewis structure, and they have exactly triple bond, the hydrogens, and the chlorine at the end. This is correct. So now tonight for question number 12.